In this video, we're going to study log functions and their properties. Okay, so what we want to start with first is what's a logarithm? Okay, a logarithm can be, for some students, a little confusing. So let me try to make it a little simpler. Okay, I'm going to use this definition a lot. It's very closely related to an exponential. Okay, an exponential expression can be a log expression, and an exponential function can be written as a logarithmic function. Or what we're going to learn is that they're inverses of each other. So it's important to review that inverse section before you do this. Remember what an inverse function is. The input becomes the output becomes the input. And we're going to see that here. Okay, so let's focus on this. So if I have this function, y equals b to the x, that's a function we just studied, exponential functions. What's a logarithm? A logarithm is this exponent. X is equal to the log base b of y. Okay, so a couple things to recognize here. For this exponential piece, which we understand, the input is x, the output is y, the base is b. An example of this would be y equals 2 to the x. Okay, that's an exponential function. In this case, it's an increasing exponential function. And you might remember the domain of this function, the exponential function, is all real numbers, which I'll write like that. And the range of this exponential function, it starts at 0, but never is actually 0 and goes to infinity. Okay, so hopefully you remember that. Now, the input, like I said, is the exponent, exponential function. With a log function, the first property I want to talk about is the relationship that is the inverse relationship with the log. So the input becomes the output, and the output becomes the input. Okay, the base is the same. This is important that we can go back and forth between these two all the time. And we're going to need to use this to understand logs. We'll kind of look at it in its exponential equivalent. Okay, so we'll get to functions in more detail later, but just think about it. If you believe me that this is the inverse, that these are inverses of each other, then if I were to write this in our standard function notation and just use x for my input, then the log base b of x, the input here has to be just positive numbers, the range of its inverse, 0 to infinity. And we'll look at some examples of this, why this is true. This explanation is this is true, this is the domain, because it's the inverse function of the exponential, which means the range has to be equal to the domain of the exponential. So the range of the log function is negative infinity to infinity. Okay, we'll revisit that later. Let's look at some examples of how to apply this. Okay, you should all agree that 2 to the third equals 8. So what's the logarithmic equivalent? Well, I write the word log, the abbreviation log. The base is the same, base 2. And then switch the inputs and outputs. The input here was 3. The output was 8. So the input is 8, and the output is now the exponent. Okay? The logarithm is the exponent. The logarithm is the exponent. Log base 2 of 8 equals 3. That's an equivalent expression to 2 to the third equals 8. All right, how about the other way around? There's 3 parts to identify, right? There's the base, there's the input, and there's the output. So 5, 2, the input is now 2, the output 25, which makes sense. 5 squared is 25. Okay? What if I just asked you to evaluate logs? Can you apply that property? All right, well, let's take a look. Evaluate some log expressions. So you can convert it to exponential form, solve for the unknown, and we're going to get to these properties a little bit later. All right, so these will be a big deal, but we'll keep it simple. This is if I want to evaluate the log of a product or a quotient. We're going to get to those a little bit later, but anytime we can still use them to evaluate. But let's start with some basics. Okay, so here's your problem. What's the log base 2 of 8? Now we kind of think of logs as it's just a question. Find the log for me. What's the log base 2 of 8? Well, your problem is, you can rewrite it like this if you want, and give this a name, right? So here's this process, and then maybe you can do it an easier way. So if you say, okay, log base 2 of 8, let's give it a name, we'll call it y, and then we do the conversion we just did, 2 to the y equals 8. Base is the same, the output becomes the input, and the input becomes the output. So 2 to the y equals 8, and then you say, okay, well, what does y have to be? Y has to be 3, right, because 2 to the third is 8. So that means the log base 2 of 8 equals 3, based on how I converted it to exponential. Now, if you don't want to do that, you could just say, let's do another example. Let's do another example of evaluate. I'll give you one. Find for me the log base 3 of 81. So you can rewrite it like we did with this one, or you can just understand that you need an exponent, right? It's your question is 3 to what power? 3 to what power gives you 81, right? So 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. So if you're able to do that without doing the conversion part, you're just kind of doing that in your head, right? 3 to what power is 81? Then the log base 3 of 81 is equal to 4. All right, let's do some practice. So go ahead and pause this and see if you can convert. So you're given the whole exponential, you're given the whole logarithm. See if you can convert it from one form to the other. For example, log base 3 of 9 equals 2. All right, if I were to convert the other way, 3 squared equals 9. The log base 100, log base 100, of 10 equals a half. So that's 10 to the 1/2 equals, or 100 to the 1/2 equals 10. 1/2 is a square root. How about this one with just some variables in there? A to the 6 equals y. So that's log base what? Base A. Output becomes input. Input becomes output. Same expression. These ones are a little faster. I always do this little trick. I go, this 2 to the 5th equals 32. 2 to the 5th equals 32. 5 to the negative 1 equals a 5th. 2 to the b equals a. All right? So far, so good, I hope. Now let's evaluate some. Okay, so before I get to part A, that should say, we got to talk about two very special logarithms. There's a log base 10 of, let's just call this a variable m. And then there's a log base e. We talked about that number e in the last section when we talked about exponential functions, a very special number e. And these are, this is what we've been looking at, logs, log base 10 of m. And I could set that equal to whatever, but the point of this is there's a special notation. It's just a notation thing for both of these. That is, you never see base 10 because it's a common base, because we have a base 10 number system. So we abbreviate. It's just an abbreviation. So I would say it's called the common log. Or you could say log base 10, that's fine. Common log. So what you do to abbreviate is you just drop the 10. So whenever there's no number here, you have to understand it's log base 10. And then the same idea with log base e, you'll never see this again. Log base e is abbreviated as the natural log, and it's a little backwards because it's, instead of it NL, natural log, it's LN, just to fit the kind of the same spelling as we have for the rest of them. LN of m. Okay, so the log base e of m is the natural log of m. The log base 10 of m is the common log of m, no 10, no little e. It's the only two logs that don't have the base identified. You have to understand that it's assumed. Okay? So in this case, then if you want, you can put the little e here. And the question you're asking yourself is, base e to what power gives you e? So if you wanted to do the exponential equivalent, we could call that y. And then you understand the base is e. And then you could rewrite the exponential expression if you want. E to what equals e? Well, it's got to be 1. Y would have to be 1, which means this. Which means this is equal to 1, equals 1. Okay? Okay, so that is the natural log of e equals 1, because e to the first is e. How about this? What's the log 5, base 5 of 25? Well, 5 to what power is 25? 5 squared. Ooh, this is a good one. The log base 2 of 1/16. 2 to what power is 1/16? 2 to what power is 1/16? Well, you got to remember your exponent rules here. It's got to be negative. Remember that, because 2 to the negative 1 is a half. 2 to the negative 2 is 1 over 2 squared, which is 1/4, and so on. So what would I have to do to get a 1/16? It should be 2 to the negative 4, I think, is 1 over 2 to the 4. As long as 2 to the 4 is 16th, I'm correct. 2 times 2 is 4, times 2 is 8, times 2 is 16, which means this answer has to be negative 4. Okay, in the next video we'll talk about these properties of logs, a quick introduction. You might remember your exponential properties. For example, do you remember what x to the n times x to the n is? There's a bunch of these properties for exponents. It's not really part of this course, so you might want to review these. It's a prereq, exponential properties. Should be an M. So for example, what would x to the 6th times x to the 2nd be? Is it x to the 12th or x to the 8th? Well, the answer is x to the 8th, right? The shortcut is to add your exponents. So that's your exponential property. So what we're going to do in the next video is look at your log properties. Basically, for every exponential property that we had before, there's going to be an equivalent log property that's kind of similar to this one.